Hi, I'm Professor Goins, and welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you're in the right spot, so go ahead and click the subscribe button. That said, let's get into the current video. In this video, I want to talk about the idea behind a one-sided limit, and let me draw a graph of a piecewise function first. So let's say my piecewise function is this. F of x is equal to, let's say it's x plus 2 if x is less than 0, and it is x minus 1 if x is 0 or larger. Okay, so a piecewise function with those two pieces. Let's go ahead and look at what the graph of this looks like. Okay, so let's see. For x less than 0, I'm using the line that has a slope of 1 and a y-intercept of 2. So that means it's going to look like, not including the y-intercept, because I'm not including 0, but it has this line right here. And then x minus 1 if x is 0 or larger. So that means y-intercept is negative 1, and it's including 0, right, because it's including 0. And then a slope of 1. I missed my x-intercept there, so it looks like that. Okay, so there is the graph of that piecewise function. Now, what I want to do is let's look at a couple of different values here. Let's start by computing the function value. F evaluated at 0. Okay, function value. When I plug 0 in, what do I get? Well, when I plug 0 in, I use the expression that includes 0 in this inequality, which would be 0 minus 1, which of course is negative 1. And again, we can see that on the graph because when x is 0, negative 1 is highlighted on the graph. So that's the function value. But what I want to focus on is not the function value, but what happens when the x values get progressively closer to 0, not actually to 0, but just that progression of getting close to 0. What are the y values getting progressively closer to? And let's start by approaching 0, but from the left-hand side. So as x approaches 0, from the left of 0, right? Okay, so the x values are, for example, like negative 1. I'm standing in the way of it. X could be negative 1, negative a half, negative 0.1, so on and so forth. What are the progression of the y values getting closer and closer to? Again, I'm not actually going to get to 0. I'm just walking closer and closer to it. Those corresponding y values are then walking and getting closer and closer to this open circle. So that means as x approaches 0, from the left of 0, the function values get progressively closer to 2. Okay. Now, let's approach 0 from the other side. As x gets progressively closer to 0, so let me write this up here as well. As x approaches 0 from the right of 0, okay, so x gets closer to 0, like 1, a half, 0.1, 0.01, etc. The function values get progressively closer to, well, in this case, negative 1. Okay. Now, Up here, the value gets closer to 2, the value gets closer to -1. -1 happens to also be the function value, but these three different concepts are all independent. They could have all three different values, because I could have just as easily had, alter it as follows. I could have said x minus 1 when x is strictly positive, and it is, let's say, -3 when x is equal to 0, which would have then put the function value actually down here. And so the function value, the value from the left and the value from the right would all be separate, right? They'd all be independent. They're all independent values. But let me go back to the original example just so I don't kind of, get this confused up here with what I already have written. So we had that, and then we just deleted those guys, and then we changed that to greater than or equal to. Okay. So the idea is that the function value and what I approach from the left and what I approach from the right are all three separate concepts. This function value represents when x is actually there, what is the y value. Whereas this one on top represents as x gets closer to 0 from the left, what are the y values approaching? What is the trend of the y values? Over here, as x approaches 0 from the right, what is the trend of those y values? What are they getting closer to? Now, these two concepts, let me erase, I guess, this side right here, are called one-sided limits. So this one is called the left-hand limit. And the way we write this is the limit of the function f of x as x approaches 0 from the left is equal to 2. And again, as x gets progressively closer to 0 from the left, what are the function values getting closer to? This one is called the right-hand limit. And the notation is the limit of the function as x approaches 0, and then the plus sign indicates from the right, negative sign indicates from the left. It does not mean positive, negative values. It just gives me a direction from the right, from the left. And this, in case, was equal to -1. Okay. So that's what we mean by a left and a right-hand limit, is what are the, as the x values progress closer to a number from either the left or the right, what are the y values of progressively getting closer to? Okay, and that's different from a function value. Okay, in a follow-up video, I will go through more examples. In this one, I wanted to just explain the basic concept between a left-hand limit and a right-hand limit. Thank you for watching. Please consider subscribing.